An educator claims that the average salary of substitute teachers in a school district in Pennsylvania is less than $60 per day. The random sample of 8 school districts is selected, and the daily salaries in dollars are shown. Is there enough evidence to support the educator's claim? All right, so we know what alpha is, and then they gave me data, and they gave me nothing else really in here. So what can we decide? Table. So I should put all this in a list and find the mean number for x bar, or just run my data on it. The only other thing I do have is, what's the 60 per day? That's the mu. So that's my population one that we're talking about. And let's create our hypotheses before we go to the calculator. So what's the null? Mu equals 60. And what's the alternative? Mu is less than 60. Because the educator's claiming that the average salary in Pennsylvania is less than. Where does that put your claim? In the alternative, because they're claiming that it is less than it. So your claim's in the alternative. All right. So now that I know that, I can put all this data in a list and then run my t-test with data. Or if I want to work it by hand, I can figure out the mean and the standard deviation and work it from there. Either way, it doesn't make a difference to me. We are running a t-test on it, yes. The frequency is always 1. So once I have my data in, I'll go back and we're going to run a t-test just for one sample with data. We know our mean is 60, and I put my data in list 1. You want to keep your frequency at 1. We put each number in once, and they don't have more than that as a frequency. Which one of these is my less than test? The middle one. It's kind of confusing, but it is always the middle one for a less than test, and the far right is your greater than test. Does everybody find this? It's the data, because it won't let you put a list in unless you tell it you have data. And then we're going to enter and see what it gives us. So the test statistic t is negative 0.626. So I've got t equals negative 0.626, and our p-value was 0.2756. I forgot my picture. But my picture would be a left-tailed test at the negative, actually this should be further in, negative 0.626 and out. What do I compare the p-value to? Alpha. So we're going to compare it to 0.10. Am I less than or greater than? Greater. So what does that tell me? Fail to reject. So what does that tell me as far as my conclusion for this? Is there evidence or not evidence? There is not sufficient evidence. And what are we doing? Are we supporting, not supporting, rejecting? So it would be support. So there's not sufficient evidence to support the claim that the average salary for substitute teachers is less than $60 a day. And we could be more specific and say the Pennsylvania substitute teachers, because your salary is going to be dependent on where you are. Questions on that? So everyone get it to work?
So, first on the last one on the things that you gave us. So when the p-value is greater than 8, you can also use that?
Yes. The critical value for this, well, let's see. First off, we have how many data points? What's my n? So my degrees of freedom is 7, and alpha is 0.1 in one tail. So I'm going to go look at the one-tailed version with 7 degrees of freedom. Let me clean some of this up. So 7 degrees of freedom puts me in this row. And this time I actually want to look at the one-tailed column. And I've got 0.1 in that tail. So my critical value is 1.415. But since it's the left tail, you actually want the negative version of it, because you're on the left side of 0, so it should be negative value. So we're going to say our critical value is negative 1.415. So T alpha is negative 1.415. And if we were to put this value on our picture, negative 1.415 is way out here, and our T value, T test statistic, fell on the inside of it, so we would still fail to reject. Does that make sense? Other questions? No, I don't. Either method is fine. Let's do, I think we can get this last one done. We'll do a speedy version. So if a physician claims that joggers' maximum volume uptake, or oxygen uptake, is greater than the average of all adults, a sample of 15 joggers has a mean of 40.6 milliliters per kilometer and the standard deviation of 6 milliliters per kilometer. If the average of all adults is 36.7, is there enough evidence to support the physician's claim? All right, so notice they started telling me about a sample, which tells me n is 15. They continued that sentence and told me about a mean, which means that that is my x bar. They also continued that sentence and did not end it until they told me about a standard deviation. So that information is all in the sentence with my sample, which makes that S instead of sigma. It's the sample standard deviation rather than the population. Then they end the sentence and they tell you the average of all adults. What does the word all mean? Population. So mu is equal to 36.7. And then, of course, we have our alpha of 0.05. All right, what's the null hypothesis? Mu equals the 36.7. Now, the physician is claiming that the oxygen uptake is greater. So what's the alternative? Mu is greater than 36.7. And which one has the claim in it? Alternative. This turns out to be a right-tailed test because we're looking at the greater than side. And let's find out what our test statistic T is and our p-value by running a t-test. So we're going to go to stats and test. We have the sample standard deviation, so it's a t-test with statistics rather than data. So 36.7. And then we've got 40.6. And we have 6 for the standard deviation. N is 15. And we're doing a greater than test, which is all the way to the right. That's my greater than piece. And let's see what we get. So our test statistic is 2.517. And our p-value is 0.0123. So I've got 2.517 up there. If I compare my p-value to alpha, am I less than or greater than it? Less than. What do we decide when it's less than? The p-value is low, so we're going to reject. And then, what does that tell me? There is evidence to support the claim, right? Because the claim's in the alternative and we rejected the null. So we're going to support the claim that the average oxygen uptake is greater than 36.7 for joggers. And if we wanted to find our critical value, our degrees of freedom would be 14, and we still have 0.05 in one tail. So we're going to look at one tail. I'll come back down to that. So 14 degrees of freedom, 0.05 in one tail, gives me a critical value of 1.761. And we notice if we put that on our table, we've got 1.761. We are to the outside of it, so we would also reject based on our critical value.